Hi, boys and girls. So today we're doing Chapter 13, Lesson 9, Area and Perimeter. So it's really important that you know the difference between area and perimeter. So you learned perimeter and then you learned area, and now we're combining the two because sometimes a space can have the same area but have a different perimeter, or it can have the same perimeter and a different area. So our learning intention is I'm learning to find the area and perimeter of figures so that I can measure boundaries and spaces. So this will be important if you are ever building something like a birdhouse or a tree house or a patio, a deck, anything like that. It can be something small, a small project. It can be a really large project. So we learned about George Washington. He was a surveyor and he had to measure boundaries of things. So he would have been really good at perimeter and area. Okay, so our vocabulary that we need to remember is area is the number of squares that cover a figure. Remember, you're measuring the space, the surface of a figure. And then for perimeter, you're measuring the distance around the outside of the figure, like a border, like a picture frame or a fence, something like that. Okay, so let's move on and take a look at the pages we're going to be doing. Now, our independent practice is not from the book, so I'll be talking about that when I get there. Whoops, it's not what I wanted. I wanted to make it bigger. For that, I can use my fingers. Okay, so first we're looking at, oops, made it too giant. We'll be doing page 805 in our math books and 806. And then we're going to do this independent practice page, and I added some directions to it. So you'll have to listen carefully to the directions. Now, if you're not in my class, you're probably not getting this page. So you can just totally stop once we get to the end of page 806. Okay, but we are doing pages 805, 806. Then my class is doing an independent practice worksheet. Okay, so let's get rolling here. So two rectangles can have the same area but different perimeters. That means that the space inside the perimeter can be the same even though the outside edge measures differently. So let's take a look at an example of this. So Elizabeth will build two fences, one surrounding each garden shown below. How much area does each garden cover? How much fencing will she need for each garden? So they're asking for two things. First, the area of each garden, and then how much fencing. Now, just a little hint, when you are doing this on a test, I recommend that you number how many questions you have so you make sure that you answer them both. Okay, so I would do a 1 and a 2 like that. Now, when you're taking the state test, obviously you can't draw numbers, but you can highlight them in different colors, and then you can write on your scratch paper, like say you pick purple for number 1, you can say purple, question 1, yellow, question 2, like that, so that you remember that you had 2 questions you have to answer. Okay, so first let's find the area of each garden. So garden 1, area equals length times width. This is called a formula. That means that it is a way of solving a math problem where they don't give you the numbers, you have to substitute the numbers. So A means area, the cursive L means length, and the W means width. Now, most of the time, length is the long side, and width is the wide side, the shorter side. But sometimes people will change those around depending on the direction of the figure. The most important thing to remember is that you use the two different sides, that you don't use sides that are opposite each other. So I wouldn't want to multiply 6 and 6 because that's not the area. That's two lengths of this. That's two lengths of the rectangle. In order to figure it out, we have to treat it like an array and have 6 rows, or 2 rows, 6 in each row. So anyway, however you choose to think about it, just remember you need the two different side lengths in your multiplication. So the length in this case is 6 feet. So here's the 6. And the width is 2 feet. So here's the 2. So I'm going to multiply those. And because I've been learning my math facts, I know that the answer is 12. And because I'm doing area, I know that it's square feet. So because area is always measuring in squares. So square, and then we're not using units because the problem told us that we're measuring it in feet. You can write F-E-E-T if you want, or you can put F-T period. That's the abbreviation for feet. Okay, garden number 2. Once again, let's highlight what we need to know. So area equals length times width. The length, the long side, is 4. Here's the long side. And the short side, the width, is 3. Now we know because of commutative property, if we switch them around, we're still going to get the same answer. So it's okay if you're thinking of it a little differently. Just understand that length is normally the long side, width is normally the short side. So 4 times 3 is 12. So these gardens have the exact same area. They're both 12 square feet. But now let's find the perimeter of each garden. So garden 1, we need to have the measurement of all 4 sides. So we know that, let me switch colors here so we don't get too confused. We know that this side is 6 feet, and we know this side is 2 feet. Now in a rectangle, the opposite sides are equal. So this one is also 2, and this one is also 6. So we just put that into a number sentence down here, 6 plus 2 and 6 plus 2. Now when you add these, just like we saw in the brain pop video, it's easier to make long addition problems into shorter ones. So 6 plus 2 is 8. 6 plus 2 is 8. 8 plus 8 is 16. Now, we're not measuring squares. We're doing linear or line measurement. So we just leave it with feet. There's no squares involved. So we just say feet, no square feet. Okay, so then on this other figure, we have 4 feet here. So we know the opposite side, because it's a rectangle, is also 4 feet. We have 3 feet on the width. So the other width is 3 feet also, because opposite sides are equal. So here we have the numbers 3 plus 4 plus 3 plus 4. So now we're going to make that simpler. We're going to do 3 plus 4 is 7. 3 plus 4 is 7. I know it looks like a 4. 7 plus 7 is 14. Again, they're not square feet. It's feet because it's linear. So garden 1 needs 16 feet of fencing and garden 2 needs 14 feet of fencing. They have the same area, but they have different perimeters. And that is because of the size of the sides. Okay, so again, both have 12 square feet inside of them, but you need different lengths of fencing because the sides are different sizes. Okay, so let's go on to the next page. And let's look at a situation where 2 rectangles have the same perimeter, but different areas. So we're going to draw and label a rectangle that has the same perimeter as the rectangle shown, but a different area. So look at number 1. Find the perimeter and the area of the rectangle shown. So again, we're going to look at the perimeter. So this side is 6 inches. So we know this side is also 6 inches. This side is 4 inches, so we know this side is also 4 inches. So we just put it out here into a number sentence because you add up all the sides. 6 plus 4 plus 6 plus 4. I know 6 plus 4 is 10, and 6 plus 4 is 10. Okay, so that is 20 inches. The area is 6 times 4, the length times the width, or 24 square inches. Okay. So now we're going to do a shape with the same perimeter, but different areas. Draw and label a rectangle that has a perimeter of 20 inches, but a different area. Okay, so here's my default that I go to. I like to do 1 times something because that's easier. So if it's going to be 20 inches around, you have a 1-inch side, then you have this long side, like this. So if the perimeter is going to be 20, if this is 1 inch and this is 1 inch, that's 2 inches, or yeah, 2 inches. And then I know I have 18 more inches. So I'm going to do 9 here and 9 here. So 9 plus 9 is 18, 19, and 20. So I have 20 inches. But my area is going to be 1 times 9. 1 row of 9 squares. So it's going to be 9 square inches. That's my go-to. I just make the width 1, figure out how much all the other sides need to be, and then I do the area. And that should work most of the time. Okay, so what is the length of the rectangle we drew? The length is the long side, so it is 9 inches. I'm going to do IN period for my label. What is the width of the rectangle I drew? 1 inch, 1 IN period. What is the area of the rectangle you drew? And 1 times 9 is 9 square inches. Sorry, it's messy. I'm writing with my finger and I'm trying not to hit my microphone because I'm doing this from home. Okay, so let's describe the length and width of a rectangle that has the same area as the one below, but a different perimeter. So same area, different perimeter. So first of all, let's figure out what the area would be. So 8 times 4, write that inside your rectangle. Pause the video and then come back. Okay, I think I said 8 times 4. I meant 8 times 3. So 8 times 3 is 24 square yards. To save space, I'm going to do SQYD. That's square yards to make it short. Okay. All right. So we know that this has 24 square yards. So now we need a figure that has a different perimeter, but the same area. So I want you to think of another expression that equals 24. It can't be 8 times 3. Pick a different 2 other numbers that you can multiply that equal 24. Pause the video. Okay, if you went to my go-to, you would do 1 times 24. So you could do a 1 by 24. I'm going to write them up here. You don't have to write all this up here. You could do a 2 by 12, because 2 times 12 is 24. We already did 3 times 8, so we can't do that. You could do 4 times 6. And then it just starts flip-flopping around. It just does commuted properties. 6 times 4, 12 times 2, 1 times 24. So you can use any of those for your answer. And the perimeter is going to be different. So I'm going to pick 6 times 4. And the perimeter of a 4 by 6 rectangle would be 6 plus 6 plus 4 plus 4. 6 and 4 is 10. 6 and 4 is 10. 10 and 10 is 20. Okay. The perimeter of this, the one they gave us, this is 8 over here. This is 3 over here. 8 plus 3 is 11. 8 plus 3 is 11. 11 plus 11 is 22. So it's 22 feet, or 22 yards, sorry. So the perimeters are different. So let's write about that. We're going to do this together. Oops. Okay, so the length, oopsie, how did that happen? Let's try that again. Okay, I'm going to move this down so we can see what we're working with here, and then we can slide it back up. So the length and width of the first figure is 8, can't type, 8 and 3. Make this smaller so it fits. Okay. The length and width of the second figure is 6 and 4. They both have an area of 24 square yards, but figure one, we'll just call it figure one, even though it's not labeled. Figure one has a perimeter of, what do we say, 22 yards. And figure two has a perimeter of 20 yards. Get the lot to get on your page there. So you'll have to adjust your text box. You'll have to adjust your font size just like I did so you get it all on there. So we answered the question. Describe the length and width of a rectangle that has the same area as the one below but a different perimeter. The length and width of the first figure is 8 and 3. The length and width of the second figure is 6 and 4. They both have an area of 24 square yards, but figure 1 has a perimeter of 22 yards and figure 2 has a perimeter of 20 yards. Okay, let's move on to the independent practice. For everybody that's not in my class, you can stop the video now and go on with the assignment your teacher gave you. For my class, here is what you guys are going to do. Now, I added directions to this. So you're going to find the area A and perimeter P of each shape. Now, they have you labeling it with that little exponent 2. And so basically that means squared because you're doing a two-dimensional figure. You're doing length and width. So when you're doing area, you're going to label it with this cm squared. They're all cm squareds. And all of them need to be labeled. So this is your label right here. Okay. When you do perimeter, you just do cm. Okay. So what you're going to do is count the squares in each box, or you can multiply to find the area, and you're going to write it on the blank that says A. Then you're going to count all the spaces around the outside or write the measurements of the outside. Like on A, I could have done this. Okay, 1. Oh, you can't really see that very well. Let's try a different color. Let's try pink. So 1, 2, 3 spaces this way. 1, 2, 3 spaces that way. 3 times 3 is 9 centimeters squared. Okay. And then you know that this side is also 3. This side is also 3. 3 times 4 is 12. 12 centimeters. Okay. I'm going to get rid of this because it's really getting busy on here and there's still more directions. Okay, so like on this one, on letter B, you can't really do length times width. So you're really going to have to count carefully, count those edges, and you can use your drawing tool if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the perimeter on this one is 10. I'm not going to write in highlighter either. Okay, so 10 cm. Okay, then the area, I'm going to count the squares. 1, 2, 3, 4. So it is 4 centimeters squared. Put that 2 up high. Okay, it's called a superscript. Okay, now I've shown you how to do that. Here are the next 2 directions. You have 3 directions. So first of all, you're going to find the area and perimeter of each shape. So go through and do all the areas and perimeters for each shape. Okay, then number 2, you're going to go back and circle 2 figures that have the same perimeter and different area. So you're looking at the perimeters. When you find 2 that have the same perimeter, make sure the area is different. Circle those 2 figures. If you want to just circle the little letter, that's fine. I don't care. Okay, or you can circle the whole thing. It doesn't matter to me. Whatever works best for you. Then direction 3 says draw a box around 2 figures that have the same area and different perimeter. So you're going to look at your areas, find two figures that have the same area, and draw a box around them. Okay? So, and however you want to do the boxes, you can do the box around the letter if you want, or you can do it around the whole thing. That's entirely up to you. So if you are not sure of what to do, come back to this video and watch it again. Look at how we did the other 2 pages. That's the point of these videos, is that you can go back, play it slower, play it faster, find just what you need, pause it, and then continue, whatever. So there you go. So you have 3 things that you have to do on this page. So good luck, and that is how you find area and perimeter.